Okay, so you take screenshots of all your work from the MATLAB window, be it the editor where you are writing the code or the command window where you are writing like the one-line commands. Paste them on a Word file and make just one Word file for the entire homework. So it should contain all the questions. And this is also incidentally how you are going to do the test as well. So make a single doc file with all the questions and the screenshots for all the questions. And you upload that one Word file on the D2L Dropbox. And you should also upload any .m file that you might have created. So a .m file is when you write a code and you save it under your MATLAB directory as a .m file. So if you have .m files for that homework, upload them as well. But the most essential thing is this Word file where you have the screenshots of all your work. And as I said, the homework assignments will be due just before the Thursday class. So right now, this Thursday, you have just one homework set due. But from coming Thursday onward, you will have two homework sets due on the Thursday. So there will be a homework that I'm going to announce at the end of the lecture today and another at the end of the lecture on Thursday. So both those homeworks will be due on the following week on the Thursday at 11 a.m. And yeah, so most of you know this by now. So the homework sets will be at the on the last page of the PDF that I'm going to upload after each lecture. And so that you know, the homeworks are going to be graded by my TA, Mukesh Roy. So if you have any questions, you can get in touch with him. He can help you out with the homework questions, or you can email me as well. And if I think that he can help you out quicker, then I'll just redirect your email to him. And also at the end of the lecture today, if any of you has questions on the first homework, you can hang around on the Zoom and I can try to like help you out. Okay. So let's go to the lecture for today. By the way, how do you guys feel about homework 1? Is it too difficult or are you able to manage it? Is it manageable? Anyone? It mostly should be command windows where you are doing the work. And for the last problem, you can actually use the code that we wrote in the last lecture. And I think I almost solved that last problem in the class. Like when you were trying to make MATLAB ask you the question like, what is the radius? So I think we did solve that in the last lecture. So this first homework should not be that challenging, but some of the upcoming homeworks can be a little difficult. So make sure that you allot enough time to work on them. Okay, so let's start with the lecture today. And as I said, our first class was supposed to be the very basics of MATLAB, like how you do calculations on the command window and how you write a simple code, a simple script. From today, we are going to look at how MATLAB actually does the work. And I think I told you in the last lecture that MATLAB is really good with numbers. And when I say that it is good with numbers, it means that it has a special tool that it can use on almost every problem. And that tool is matrix or arrays. So it tries to reduce every problem into the form of an array of numbers. Now you might ask, what is the difference between an array and a matrix? Can anyone tell me what is the difference between an array and a matrix? Just take a shot, anyone. So do they mean the same thing? How many of you think they mean the same thing? And how many of you don't think that it's the same? Yeah, so both of you are partially correct. So an array is a much more generic class. So an array can have more than 2 dimensions. It's a set of numbers, true, but it can have more than 2 dimensions. And when we are just thinking about 2 dimensions, like some numbers are arranged in the form of a table where there's some number of rows and some number of columns. So that is a matrix for you. And most of the times when we are dealing with arrays or matrices on MATLAB, we are basically talking about a matrix where you have a 2D array of numbers. And MATLAB is going to do all its work for every problem by reducing the problem to such matrix of numbers. So I think over here, my notes are still handwritten. I think from next lecture onward, or the fourth lecture onward, it would be all in the form of slides. Let me know if you have trouble understanding my handwriting. But anyway, so here I explain the basics, the theoretical basics of arrays and matrices. On MATLAB, we are dealing with 2D arrays, and hence they are matrices. And then I have a few things that you need to know on how to enter these numbers on MATLAB and how you can process different things out of those matrix operations from MATLAB. So let's now move into the MATLAB window. And if you guys have MATLAB open, just make sure that you're ready to type after me. All of you have installed MATLAB on your computers now, right? So make sure that you just do whatever I'm doing in class, and that would be a good practice for the homeworks and the final and the exams.
Excuse me, sir.
Yes.
I don't have MATLAB on my computer.
Okay, if you don't have, then unfortunately you cannot follow the codes that I'm going to write now, but go to the D2L and go to the content, and I have uploaded a collection of slides that would tell you how to install MATLAB. So this is MATLAB installation updated.
Okay.
So try to follow those. And I think you should be connected to the university Wi-Fi, the campus Wi-Fi, while you install the MATLAB. Or you can connect your computer to VPN and then try it. But I might be wrong on that, but just try to follow these instructions. But make sure that you have MATLAB ready by Thursday.
Yes, sir.
Okay, so rest of you, let's work on our respective MATLABs. So the first thing that we are going to do today, mostly we are going to use the command window even today. But as we saw in the previous class, command window is nothing but the building block toward a big code that you might be writing later on. So whatever you do on the command window is eventually enriching your knowledge on how to write a complete code. But let's work through the command window for now. So what I have on the lecture note is how to provide MATLAB with the information on a matrix. So how to initiate a matrix into MATLAB. So suppose I'm trying to develop this matrix A, which has 3 rows and 3 columns, and I want MATLAB to know what A is. So for that, this is the syntax. So you type A equal and then square bracket, and then you enter each row at a time. So if the first row here is 1, 2, 3, you type 1, 2, 3 with space. Then to go to the next row, you press a semicolon and then 4, 5, 6. To go to the third row, again a semicolon, and then 7, 8, 9. So now if you press the enter, you'll get that A is this. So now MATLAB knows what is A. So this is how you introduce a matrix to MATLAB. Now, once MATLAB knows what is A, you can also ask MATLAB about the different elements or different parts of A. So for example, if I ask MATLAB what is the element that A has in the third row and first column. So third row means 1, 2, 3, this row, and and the first column is this first column. And that element is of course 7. So let's see if we can figure that out by asking MATLAB that question. So the way we write this is in this form. So the first placeholder is the row number that we are trying to extract, which in this case is we are trying to extract the element from the third row, so 3. And we are trying to extract 7 here, which is in the first column. So for the first column, the corresponding column number is 1. So if I press this, we get 7. Okay. So what we are doing here is this. So extract, say, the element from the second row and third column. So what should be the syntax for that? So second row, so the placeholder for the second row is 2. The placeholder for the third column is 3. And second row is this, and this row, and the third column is this, so it should be 6. And there it is. So once MATLAB knows that this A is a matrix, you can extract any element out of which by just setting the row number and the column number. Okay, let's now do this. A 3, 4. And we got an error. Why did I get this error?
Because that's not in the matrix.
Because this, you're correct, because this 4 stands for the fourth column and it doesn't have any fourth column. So this is pretty evident right now here, but later on when you don't really get to see the matrix, when you are trying to like solve a problem by writing a code, make sure that you don't exceed the column number or the row number when you are trying to extract this kind of positions. Okay, so this is what I have explained over here until now. Let's look at something else. So the next question is extract the second and third rows and the first and third columns of A. So what I mean by this is, if your A is this, the second and third rows are 4, 5, 6, and 7, 8, 9, and the first and third columns of A. Okay, let's for now do this instead of just first and third. Let's do this first, second, and third. So we are going to extract second and third rows and all the columns. So let that new matrix that we are trying to develop from A be B. Now again, we have to think about the first place to be the place that denotes the row numbers and the second place within the parenthesis after A to be the one denoting to the column numbers. But here it is asking for just the second and third rows. So the way you do it is this: 2, 3. This implies in regular language 2 to 3. So 2 to 3, then a comma, and then you need all the 3 columns. So 1, 2, 3. So if I type this out, you get the second and third rows and all the 3 columns. Okay, so this is what I have here. Now if I instead do this, if I do C equals to A 2, 3, that means second to third row, comma, and this one single colon instead of any number for the column places, we still get the same thing. So what this means is, if I want to shorten the syntax, and suppose we are extracting all the columns or all the rows, we can just use this semicolon. So to give you more examples of this, so if I do this, colon, comma, 1, 2, 2. Can you tell me what the output is going to be like? How many columns, how many rows should be there in this output?
It should be
all 3 rows.
3 rows, because here this colon would stand for all the rows, and A originally has all the like all 3 rows, so there would be 3 rows, and first column to second column, so there should be 2 columns. And there you go. So this is just this part of the matrix.
yeah.
So these things might come up on the test with as short 2-point questions, where I might ask you to, so I might give you a big matrix, and from that matrix, I might ask you to do different kinds of operations. Okay, so let's do a few more things. Let's do something like this. So suppose we have A. So let's type A again. So we have this A, and let's clean this space up before we go any further. So what is the command to clean up the command window?
CLC.
CLC, right? So CLC, but don't do clear all right now because I still want to use A from the MATLAB memory. So A is still 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose I'm trying to come up with a new matrix which doesn't have this first column. Okay. So let's see how we can do that. So let that the new matrix be D. I'm trying to skip out this first column. So it can be as well as this colon and then 2 to 3. Right. Now it can be something else as well. So let's think about this. So I'm just trying to do the same operation in different ways. So if I type something like this, A colon comma 1, what do you think the output is going to be? So A colon means all the rows, and 1 is the only information that I'm supplying MATLAB in terms of the column number. So what should be the output like?
The entire first column.
That's the first column. Right. But now if I do something like this, A colon 1, but instead of just pressing enter over there, I do something like this. So what this means is, this particular symbol means a null matrix. So what it would do is remove whatever was stored in that position of A. So let's do that. So what happened is, I tried to remove this first column, and you remove that first column by doing this, and you are left with whatever was left of A after you remove that first column. So using this null matrix, you can remove any part, any subpart from a matrix. So the other example that I have on the lecture note is this. So we had B to be 4, 5, 6, 7, 8, 9. Now if I press B semicolon comma 2, and if I use the null matrix again, so colon means all the rows and 2 means the second column. But if I assign this second column to be a null matrix, this 5, 8 would be removed from B. So if I press and enter now, B gets revised to just whatever is left of B after MATLAB removed this 5, 8 out of B. So 4, 7, 6, 9. So you get the point. So using this null matrix, you can actually erase parts of a matrix. And its size would change, of course, because you are removing some elements out of it. But this is sometimes very handy when you are doing a number of manipulations on MATLAB. Question? So as I said, you can do the same operation in multiple ways, and I don't have any kind of restrictions on how you want to do it. Just try to practice this syntaxes, and after a while you'd get a sense of how you might want to do each operation. Okay, so let's carry on further. And actually we have edited A to this form, but let's go back to the original A we had. So let's do CLC, and let's do a clear all and a CLC, and let's again input A into MATLAB. So again 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I again have this A. So there is another term that we are going to learn today is what is a vector. So a vector is a matrix which is either having a single row or a single column. So for example, if I type this A, 1, comma, colon, what does that mean? 1 stands for the row number, so this first row, and colon, as I have been saying, is standing for all the columns or all the rows based on wherever you place that colon. So first row and all columns means 1, 2, 3. So if I press this enter, we would get this 1, 2, 3. So this is an example of a row vector. So as I said, a vector should be either one single row or one single column. So this is a row vector. Now if I do something like this, so x is equal to this very same operation, A first row and then all columns, which is a row. But if I do a transpose operation, transpose means you are just shifting the row and column numbers and interchanging them. So it is done by this single quote. You'll end up getting a column. So 1 stays at its position, but 2 goes underneath this 1 and 3 gets underneath this 3. Okay. So this is an example of, I don't think I have written it on the lecture note, but this is an example of a column vector. Okay, I'll edit the lecture notes later on. So this is an example of a column vector. Okay, somehow when I'm on the full screen, this doesn't work, okay. Okay, let me pause the share for a moment. Can you see my screen? Okay. So this particular structure where you have a single column is a column vector. Now let's do a few operations with this row vector and this column vector. So let's again revisit what we had as x. So x is this column vector. Now if I do x transpose, what should we get? We should get back this row vector that we started out with, 1, 2, 3. So now let's look at how we do vector multiplications. So if I do x star and then multiplied x, the answer is 14. Now here I have the calculations done. So 1, 2, 3 being multiplied, a column vector being multiplied by this row vector. So this gets multiplied to this, 2 times 2 and then 3 times 3. So it is indeed 14. I'm presuming all of you have done matrix multiplication at some point. So whenever you see some questions, and there would be a question like this on the test, which would be on matrix multiplication. If you have any doubts that it's not working on MATLAB or you are getting an error, you can do it by hand to figure out where the error might be, and then try to revise your code or whatever syntax you are using on the MATLAB window. Okay, so let's do a few more things with matrix multiplication. So we are again working with this A, and we have the x as a column vector. Now let's do x multiplied by A. and we got an error. So can you tell me why we got this error?
Matrices are the wrong size.
Correct.
Multiply
Very
by.
correct. Yeah, so when you do any matrix multiplication, you need to be really careful that the matrices are indeed ready to be multiplied. So here I have sort of tried to show what I mean. So if you're trying to multiply a matrix A with a matrix B, and if M by N are the number of rows and columns in A, and N and Q are the number of rows and columns in B, then the number of columns in A and the number of rows in B, they should be the same. So what happened here? A was a 3 by 3 matrix, right? On the other hand, sorry, the X is a 3 by 1 matrix, and this A is a 3 by 3 matrix. So there is a mismatch. So the number of columns in X and the number of rows in A, they are not equal. So it didn't really work. But on the other hand, if I instead multiply A and X, we do get an answer. So this is the nuance of matrix multiplication, which I'm presuming you have done before, that it is important in what order you multiply the matrices. And this would come up in this course as well. So make sure that you understand this when you are writing your code, that the matrices are of the proper order when you do the multiplication. Okay. So the next thing that we are going to do is this. So A square, what it does, so this is the output, but what A square means is A multiplied by A, simply. And see, you get the same answer. But sometimes I might ask you that I don't need A square. I rather want each of the elements in A to be squared. So for example, in the output, I want to have something like this. So in the output, I want to have square of 1, 1, square of 2, 4. So 1, 4, 9, 16, 25, 36, and 49, 64, 81. So square of each of these elements. So how do you do that? So there is a special operator called dot, which you're going to use here. I'll come to it in a moment. So if I do dot to the power of 2, I square each of the elements under A. Now this dot is very, very important. When you write your codes and you need to do an operation on each element in that matrix, you need to use this dot most of the times. Because the way we think about solving a problem on MATLAB, as I have been telling you, it tries to think in terms of numbers and in terms of matrices. And in most of the cases, you want to carry out the same operation on each element of that matrix. And to do the same operation on each element, you need to have this dot operator. So typically, just doing A cube might be nice to see over here in the command window, but probably while writing a code, most of the times you need to do A dot to the power 3, because then the operation is being implemented on each of the elements. Okay. So a few more things. So over here, what we have been doing today, initially this A that I started out with was a variable, and I assigned this matrix to this variable A. And similarly, I think I introduced B and C and D, all different variables. And typically, when you write a code as well, you start with some variables. So this is how you name a variable. Don't start it with any number, start it with a letter. But after that, you can use any digits, underscores, it doesn't really matter. And don't make the names too long. This is another example in terms of how to start a matrix on MATLAB. So let's do this. So you have B as this matrix. Now again, remember that we entered each row at a time. So 2x then log of x plus sine y semicolon 5i 3 plus 2i. Anyone has any correction to this? Does it look correct? So if I press and enter here, what should I get? I should get the matrix, right? But we get an error. And actually MATLAB is smart. MATLAB actually suggested what should be the corrected syntax. So I think someone emailed me a few days back with this question. On MATLAB, whenever you have something that is getting multiplied, you always need to use this plus sign. And this is one of the most common debugging errors that you can find on the MATLAB codes, that people have missed this multiplication sign somewhere, because we don't typically, when we write the algorithm out, when we write the equations out on our notebook, we typically don't use this multiplication sign, right, anymore. But on MATLAB, you always need to use this. So I would use it here as well with the I. I would use it here as well with 2i. Okay, there is one more. So unrecognized function or variable y. So of course, we still don't know what is y. So let's tell MATLAB that y is 5 and now do this thing. So the way I'm doing it is I'm just pressing the upper arrow key on my keyboard. So you can go back to the previous commands that you might have entered on the command prompt. So if I now enter this, I get this. The reason I get this, because MATLAB, if you go back to the workspace, MATLAB has some info on this x that we started out way back. So it could use this x, but if we did not have this x in the memory of MATLAB, then we would have to introduce an x as well before it can actually show what b is. Okay, any question? Okay, so let's clean this window again. Okay, so let's come to this particular example. So how to introduce a column vector. So basically I'm trying to introduce a column vector, which means that there would be some number of rows but one single column. So the way you do this is again following the same kind of logic, that you enter each row at a time. So now for a column vector, there is just one single column, right? So each row has just one single element. So whatever that element is, let that element be, the first element be 10. And that ends the row because it just has one single column. So once the row has ended, you put a semicolon. In that column vector, let the second element be 20. So 20. And that ends that second row because it doesn't have any other column. And let the third one be 30, or the fourth one be 40. And then if I press enter, you end up getting that column vector. So the logic is still the same. You upload each row at a time and you separate the rows out with semicolons. So this kind of quick questions would be there on the test. So make sure that you, and this is, for this you of course are not writing any codes, but make sure that you know how to do this kind of manipulations on MATLAB. Okay, so, okay, over here I have mentioned that this is a column vector and this is a row vector. The logic is again still the same. Suppose I'm trying to upload a row vector 1 to 5. So I would do this. I would type out the first row 1 to 5. Does it have any other row? It doesn't. It is a single row vector. So that's it. We don't need to upload any more rows. We close this, we end the square bracket and we press enter and we end up getting the row vector. Got it? Okay, so go through these lecture notes, try to repeat all the syntaxes. You don't probably need to look at the video as well either. So you can just read these syntaxes and try to type them out again on your command window. Now, for your convenience, I took this. So I think this is from a book that I was using last year for MATLAB. So I have some sample comments which you can repeat on your MATLAB. You don't need to do it right now. So it would be in the lecture notes. And if you have any questions, just shoot me an email. Okay. So this is homework 2. And as I said, this homework would be due next week on Thursday. So on Thursday, you will have 2 sets of homeworks. The one that I'm making due from today's lecture and the one that I would be giving out after the Thursday lecture. So each Thursday, you'd have 2 homework sets due. This Thursday, this week is just an exception when you have just 1 homework because we just had 1 lecture in the last class. So this particular homework would need a lot of this kind of array and matrix manipulations. So make sure that you are comfortable with what we did in the class today before you attempt these homeworks. Any question? Okay. So if you don't have any question on the lecture, let's revisit our schedule for the lab classes. So let me just pull that up. You can see my screen, right? Okay, so section 1 is Tuesday, Thursday, 1 to 1:50. Section 2 is Tuesday, Thursday, 5 p.m., 5 to 5:50, and section 3 is Wednesday and Friday. So the lab classes are going to be conducted by the teaching assistant. So what I've asked him is to basically go over some of the contents of the lectures that we are covering in the theory classes. You can ask him if you find something difficult to understand. So basically it would be a review of the lectures, for a short review of the lecture, and then I've asked him to be prepared with the homework questions as well. So as you work on the homework questions, you can ask him for help on some of the homework questions, because this first homework was easy, but the second homework onward, it would be more challenging. And he's supposed to arrange some quizzes throughout the semester. So be prepared to take some quick quizzes. So there would be at least 3 quizzes from now till middle of October on MATLAB. And in terms of when these lab classes would start, it would be starting next week. So the first class would be the Tuesday for section 1 in the coming week. So still no lab classes this week. But if you have any questions with the homework, I have included the TA's contact information on the instructions page for the homework. You can email him because he would be in charge of getting the homework. So if you have any doubts, you can directly email him or you can email me. So again, to repeat, so the first lab class would be next Tuesday, and then it would be usual for all the other classes. Any questions? Okay, so let me pull up the first homework to see if you guys have any questions on that. Okay, so this first one or the second one, the third one, and the fourth one, you don't have to write a code. You do the operations on the command window, take the screenshot of your work, and you paste them on the doc file, the Word file. The fifth one, by circle.m, as I said, is the code that we wrote in the last class. So you write that code, you generate the circle, take that graph and paste it on the doc file, as well as take a screenshot of your code So from the editor window, take a screenshot of it and paste it on the command window. And because you have generated a .m file for this 5th question, you need to upload that .m file as well. So you're uploading 2 files, one Word file with all the work from these 5 questions, including the plot that you generate, and then the .m file for the 5th question. Now, anyone has any specific question for this homework?
I was doing the third part of number 2. I don't know how to like get it to solve for x.
Okay, so let me look at it. So some of these questions would need some work on pen and paper as well. So we have, let me read this question. The basic MATLAB trig functions are sine, cosine, tan, cot, sec, and cosec. The inverse, arcsine, arctan, etc. are calculated with a sine, a tan. The same is true for hyperbolic functions. Okay, so calculate the quantities. Sine pi over 6, cos pi, tan pi over 2. And as I was
on the third part of number 2 first.
over here. Okay. So the mathematical quantities ex, log x are calculated with this. Calculate the following quantities. So third part is 3x is equal to 17. So let's go to the MATLAB window. Okay, so solve 3x is equal to 17 for x, check the result. So as I said, some of this work, because you still don't know how to solve an equation on MATLAB, so you cannot really use the solve commands. So some of it would involve you actually writing out the equation on your paper or on the doc file and figuring out how to evaluate x from that equation. So 3 to the power of x is 17. So we can write x as log of 17 over log of 3, and that's the answer. So what I would want you to do is this. So verification of the solution. So 3 to the power of x minus 17. So the 0 solve. So if x is correct, then this should be 0, because if I bring 17 to the other side, then it is 0. So let's see if that is true. It is true, but only to a certain extent. So it is a very, very small number. And have you guys done any numerical methods course yet? No? Yes? Okay. So if it is a no, then this is sort of like a first insight for you guys into how numerical methods work on this kind of programming languages. So these are not analytical solutions, these are approximate solutions. And although you were expecting an answer of 0 for this, you got something which is very small, very close to 0, but not really 0. And that is okay, because you are using some approximate tools to get these numbers. So for this particular question, I would just ask you to take a screenshot of this work and paste it on the doc file.
Yeah, that's what was confusing me, is I just never got it to 0. I never was like confirmed it was right.
Okay. Yeah, it's because all these numerical methods are at the end of the day approximate. Like, for example, when we drew that circle, it was not really a circle, right? We took like 100 points and basically connected those 100 points together. So technically it's a polygon, not a circle. But that's the beauty of numerical methods, or the difficulty that we have in numerical methods, that everything is approximate at the end of the day. Okay, any other question? If not, but if you still find something confusing later on, just shoot me an email and we can try to schedule a call, or you can also stop by at my office on Thursday morning would be fine for me. I have a busy day tomorrow. Anyways, but just shoot me an email and then we can figure things out in terms of when we can meet.
And how do we do the cosine like h? Like is that hyperbolic or what is that?
It's a hyperbolic function. So just look it up. So as I was telling you in the last class, so you need to be open to searching a lot of MATLAB related syntaxes and comments as well on the internet. So just look it up.
Right.
And make sure that when you look it up and when you try it out, you should know what cosine hyperbolic or sine hyperbolic means, because they're algebraic functions, right? They're trigonometric in some sense, but they also have an algebraic form. So make sure that whatever number you get is correct as per that algebraic formulation for the hyperbolic functions. And yeah, so if you ask me, I personally don't use the help tool on MATLAB. I typically tend to just Google them, because with MATLAB, because it's such an old programming language or relatively old programming language, you'd find a lot of forums where many of the questions that might be occurring to you would be answered. And that's, I think, one of the key ways to learn a new programming language. Just be part of those forum discussions. Any other question? Okay, so that's it for today. See you guys on Thursday.